Good afternoon, everyone, and welcome to Next. How's everyone doing so far? Enjoying the conference? Great. Well, so as you heard in the keynotes this morning, Google has been making tremendous investments in trying to help our customers take advantage of the cloud and use it to solve your most important, most critical business challenges. My name is Jack Lowe, and I'm really excited today because I have the opportunity to talk to you about a topic that I'm particularly excited and passionate about, namely, how to help customers look at their on-premise applications and workloads and bring them to Google Cloud. Sorry, technical difficulties here. So for more than 20 years, Google has been working on building applications that are cloud native, designed, run, and operated in the cloud. In fact, we have more than 8 products that now serve over 1 billion users each. These are products that you're very familiar with, I'm sure: Search, Ads, Gmail, YouTube, et cetera. And in this process, we've really learned the value of cloud-native applications. In fact, we see for applications and services, the benefits of this development paradigm really help throughout the application lifecycle. It starts with the engineers. I'm an engineer. My teams love developing cloud service applications, cloud-native applications, because you build microservices, it helps you release faster, it allows you to test incrementally, and it's just a more effective development model. But as you deploy your applications, the portability that comes with containers and smaller components have tremendous value for operationally maintaining your systems, for keeping them available. And also, when you want to build large-scale, efficient services, this model is clearly the way to go. Now, as we talk to our customers, in particular enterprise customers, many of you are going through this digital transformation, thinking about how you're going to modernize your IT infrastructure and your applications. And the question is this the direction you want to go in? And uniformly, the answer is yes. I think everyone believes that this is the holy grail. But unfortunately, the reality today is that most of IT is in this lower left quadrant here. You're running workloads that are on-premises. They're classic traditional applications. Many of these are prepackaged third-party pieces of software, software that comes from other ISVs, software that you did not develop yourself in-house. So the challenge is, how do you deal with this kind of an environment? And more importantly, how do you deal with the fact that oftentimes 70% of an IT budget goes into keeping the lights on? And that is, how do you maintain the infrastructure and the ongoing upkeep and maintenance of these workloads that are in this lower left? So as we think about how we help transition to this nirvana, to this end state of having cloud-native applications, we think about some of the challenges and realize this is not such an easy proposition. So what we find is that some customers might say, let's start with a full-scale re-architecture of our applications. Gartner terms this rip and replace. Now, while this approach might make sense and would be desirable in some cases, it's pretty complex and challenging. And certainly, if you have a lot of applications, it's hard to fathom being able to take all of them and just redesigning them all from scratch. So let's look at a few different journeys that your typical customers, that you might be considering for different applications. So a commonly understood path is that of lift and shift. So what do we mean by lift and shift? There's a bit of a taxonomy here, and I'll start with thinking about a term that Gartner and some others call lift and rehost. So this is a path where you have a workload that's running on-premises. It's probably running in a VM. And then you want to take that application and move it over to public cloud. And in this path, you're not making any changes to the software. You're not touching the application. It's basically the lowest friction way of moving this workload to public cloud. Now, oftentimes, this is still the most pragmatic and simplest approach. Again, this is pretty likely a scenario where, or a path that makes sense if this is a third-party ISV application. This could be an application where maybe you even have the source code for, but this is something developed maybe 10, 15 years ago. It largely works. So you don't want to invest or don't have the budget to rewrite it. Now, in this model, even though you aren't drastically changing the application, you can still get a lot of benefit by moving to public cloud. First of all, you don't have to pay for provisioning of capacity. You don't have to think about capacity. When it comes to the typical 3 to 5 year hardware refresh cycle, you don't have to worry about that. That's all handled by Google Cloud. But on top of that, you can actually take advantage of other principles of public cloud, such as pay by use. So many of these workloads actually will grow over time. And so what you find on premises is sometimes you'll buy a larger, overspec'd piece of hardware because you know over 3 years your database might grow in size. We've talked to some customers using SAP, for instance, and they buy hardware that's probably twice as big as what they really need because they know that they have to keep that hardware for multiple years. Well, when you're in public cloud, that's a case where you don't have to worry about over-provisioning. As your workload grows, you can naturally move it onto larger machines, and the provider, in this case, again, Google Cloud, can help take care of that for you. From a security standpoint, this is also an advantage that you can benefit from. In the keynote this morning, Diane talked about all the investments that Google has made in trying to secure our infrastructure from all sorts of vulnerabilities. One of the largest CPU vulnerabilities in decades hit the industry this year, namely Spectre and Meltdown. And because of the work that we've done in our infrastructure, not only to detect those vulnerabilities and then implement mitigations, we've been able to roll them out transparently to our users. And this is work that is certainly very critical to maintaining the security of your workloads, but it's something that Google has been able to take advantage of, and our customers didn't have to worry about at all. Now, you might say, well, some workloads I actually would like to take a little bit more advantage of the public cloud and do a little bit more than just lift and shift. So that leads to a second journey, which you can think of as lift and refactor, or lift and modernize. So an example here would be to actually move your workloads into a fully managed service. So let's say you have something like a MySQL database running on premises. Well, if you move it into a fully managed service like Cloud SQL, then you no longer have to deal with provisioning. You don't have to deal with scaling of the workloads. The backups and the patching and the upgrade of the software can all be handled for you. And in this managed service model, you still have the benefits of very low friction. You can move your workload, your database, from on-premises without having to make any data changes. And now, a lot of the infrastructure pieces, as well as the lifecycle of the application, the database layer in particular, is handled for you. So with products such as Cloud SQL, Cloud Memory Store, Cloud Dataproc, these are all examples of the benefits you can get by taking this slightly more aggressive path to cloud of lift and modernizing. Now, if you look at this modernization journey, there's also another path where some customers will say, you know what, I have an important application that I want to re-architect or modernize. And rather than moving it to the cloud, I want to actually make the modernization step first on premises. So this might be termed as improve and move. So what might you be doing here? This could be a case where you want to take your applications and containerize them, and then be able to take advantage of the benefits of using containers, separating the application from the operating system environment, being able to handle upgrades and the life cycle of these containers more efficiently. Now, this gives you some of the benefits, and then once you've taken this step now, down the road, it becomes easier to migrate to public cloud. And so what you're essentially doing is taking this daunting journey of going up and to the right and breaking into 2 steps. So we know that many IT organizations are adopting Kubernetes. I think Urs said more than 75% of enterprises are using Kubernetes today. And this is just another step that we think for many applications will be an applicable journey. Now, another approach, again, going in the direction of taking more and more aggressive modernization approaches, could be something you think of as build and connect. So for a very complex workload, what this might mean is, in fact, there are many different applications and services that together form a larger application or product. So you might have some services that are already running in the public cloud, some of them you've lifted and shifted, some that are still running on premises. And you're connecting them through various API gateways and VPN connections so that you can provide a service that spans multiple different application types, multiple journeys from your existing on-premises into the cloud. Now, I won't talk much more in detail about this journey today, but the rest of the conference, you'll hear a lot of different discussions about how you build modern applications and leverage the technologies that Google has, such as Apigee and Kubernetes and Istio. But as I've talked through these journeys, one thing that's really important to realize is the decision and how you actually get to a cloud-native future is very complex. And in fact, it's not a one-size-fits-all for any individual customer, any individual enterprise, any individual organization. You may have a very diverse set of applications that you need to support. Some might be SaaS applications, some are these third-party ISV Trimcrack applications, others are ones that you've developed in-house. You also have to think about your data center environment. You may have many data centers on premises. You might have outsourced some of the infrastructure to third parties. And then you have public clouds, and likely many public clouds that you're using. So as we all live in this diverse, heterogeneous world, and think about the hundreds or maybe even thousands, or perhaps for some of you, 10,000s of workloads that you have to run in your infrastructure, you've got to figure out how you want to manage these workloads in your migration. And the reality is, it's not a one-size-fits-all. You have to figure out what makes sense for the individual workloads that you're considering in the migration to cloud. Ultimately, we just believe in letting you run what you want, where you want. So as we think forward about making the migration to cloud, it's important to recognize that we need to plan and think about this. And I'll talk about more of this later on. Obviously, you want to be able to move quickly, but you have to make sure you're flexible and think about how are you actually going to be successful in this journey. So before you can actually start that process, it's important to take a step back and think about the holistic picture. And this is sort of like, what is the architecture, what's the infrastructure, and what's the framework that you need to deploy to be able to be prepared to start moving more workloads to public cloud. And this is an important part of your journey. So let's first start talking about hybrid. So hybrid's kind of become a buzzword in the industry, and many people use it to refer to different things. For the purposes of this talk, hybrid really is about the concept where you have applications and services that may need to run in multiple locations, and it's up to you as the customer to figure out how to make that work because you have different requirements and different constraints. This could be you have applications that are some running on premises, some running in the cloud, or it can be cases where you have applications and workloads that are in fact bursting or spanning your on-premises and your cloud. But again, you want to do what you need. We want you to be able to do what you want and do it where you want. As we talk to customers, and if you look at industry surveys and analysis, we've seen that more than 87% of cloud users have already adopted a hybrid cloud strategy. And this has been increasing in the last couple of years, so it is clearly a trend that is a reality, and it is here to stay. And in fact, not only are most customers using hybrid cloud, but the majority of them also have more than one type of cloud deployment. Now, this could be a private cloud on premises, but for the majority, it's actually a multi-cloud deployment where they're looking at multiple public cloud solutions. And as we see that 40% of these users are cloud first, this hybrid nature, this hybrid deployment is just becoming a reality, and it's here to stay for many years to come. So why are customers thinking about hybrid? Well, one, having a second source and not having just one infrastructure you depend on certainly is valuable in the case of natural disasters or other considerations. But it's also helpful as you think about being able to burst or incrementally adopt new technologies and extend your existing infrastructure. And then finally, because we can't do this massive transformation to public cloud, hybrid is a natural way to incrementally get you through this journey. So in practice, when we think about what it means to have a hybrid architecture, it's helpful to break it down into layers: networking, the application layer, and then the management layer. So let's go through each of these in turn. So first, networking means that you'll actually have an architecture that spans your different data centers. Applications, thinking about what kinds of technologies you're going to use to span this network, this hybrid network. And then you don't forget, at a management layer, you need to be able to manage, monitor, and secure solutions that are running in different locations. So if we dig in a little more deeply, starting with networking. Networking really is the underpinning to not just your hybrid infrastructure, but frankly, to your cloud infrastructure, period. Google, in our investment to support those multiple billion user products, has really invested in ensuring that we have a global network that is, the fastest of its kind, that spans the globe. So when you want to actually extend your data center to Google's network, the core construct is the virtual private cloud. So a VPC allows you to actually create an isolated network for your own private access. And the goal of creating this VPC is to make it look like an extension of your private on-premises environment, but do it so in a way that connects you and takes advantage of Google's global network. One of the advantages of Google's VPC is it allows you to bring together your services or your workloads in multiple different regions and have them all run inside of Google's network, rather than going out to the public internet. So for example, in this diagram, inside that circle, you see we have data centers in US Central, US West, and Asia East. And in all three of those locations, services and traffic can communicate with each other without having to go outside of Google network. Again, avoiding having to go onto the public internet. And what this means for you is that you get more predictable network latency and performance, and you get better performance. Beyond just connecting these regions, if you have services that are serving external users, you also get to take advantage of the global footprint that we have across the globe. So if users actually are very close to one of our POPs or one of our endpoints, then they connect very quickly, and they can get, with relatively low latency, to the Google backbone. And then the final benefit of having the VPC construct is that it allows you to have a single set of policies, a single set of centralized policies for all of your networking. So if you want to have consistent firewall rules or routing rules, that can all be done for the whole VPC, no matter how it spans the different regions. Now, in terms of connecting your own data center to the Google network infrastructure, there are three primary ways, depending on what your needs and requirements are. So the first approach would be to just use a VPN. So Cloud VPN allows you to connect one of your existing on-premises VPN gateways to Google Cloud. This can support up to 3 gigabits per second, and it uses encryption to basically protect the data in transit. Now, you might find that for your applications or needs, you might need a little bit more bandwidth. You need, basically a larger pipe to get to Google. In this case, you could use dedicated interconnect, which is available in increments of 10 gigabits per second. And here, basically, what you would do is you would meet us at one of the dedicated interconnect POPs. There are about 70 of these worldwide. And this allows you to get a really tight connection from your private network to GCP. For some of you, maybe you're somewhere in the between. So you want to use more than a VPN, but dedicated interconnect is maybe a little bit more than what you need. And that's where a partner interconnect comes in. This could also be a case where maybe your data centers aren't co-located with one of Google's data centers. And so you can bring your network to the partner, and then the partner connects you to Google. This is a turnkey solution that's available to our customers and provides network bandwidth in smaller increments, as small as 50 megabits per second. So now that we have kind of some of the networking considerations in place, let's take a step up and think about the application layer. This is where we could spend certainly hours, and there are hours of talks the rest of the next couple days looking at this application layer. But I think the key things to think about are portability, abstraction, and automation. And these are principles of cloud-native software development. Portability is something that we talk about, especially when we think about containers. You want to be able to develop your applications in a way that they can actually now easily be packaged and run in all of your different environments in your hybrid architecture, whether it's on-prem or in the cloud. Often the best way you do this is thinking about what your abstraction layer is and what APIs you've developed so that, in fact, you can run these workloads in these different locations. And then finally, automation is key. You definitely need to make sure that you automate the upgrade, the maintenance, the monitoring as much as possible so that you minimize the overhead of dealing with applications that can now run anywhere in this hybrid architecture. And then moving up from applications to the management layer, there are a few things that we've been doing and things to consider. So first, monitoring. One of the most important parts of any infrastructure and set of services is knowing how things are running and what the health of the applications and services are. So for example, Stackdriver is a suite of tools that we have available that allow you to monitor and log the behavior of applications, whether they're running Windows or Linux, whether they're running on-premises or in the cloud, whether they're running in GCP or other clouds. And having a uniform way to manage your applications and monitor them is extremely important. As you heard earlier in the keynote as well, we've recently launched Istio 1.0, which is an open platform that helps you connect, monitor, and secure your services no matter where they're running. So these are all tools that help you bring together your system so that you can have a consistent way of monitoring your entire deployment of workloads. Kubernetes, of course, is yet another aspect of managing your workloads and the containers in particular. And with the recent announcement of GKE on-prem, you can now use Kubernetes in a consistent way, not only on-premises and in the cloud, but also use GKE to manage those Kubernetes clusters no matter where they're running. This is just yet another step in trying to look at how do you have consistent management so you can simplify the number of environments and tools that you need to use as your environments get more and more complex. And then a third way to think about management is, there may be some of you who have a large VMware deployment. And for those of you who are in this situation, it may be fairly daunting to try to actually totally change your management infrastructure and retrain your staff and your people. So what we started to do is look at ways that we can integrate into some of these existing tools, in particular with vRealize. So we've developed a plugin for vRealize, and this is a joint collaboration between VMware and GCP. And the basic idea here is that we want to be able to couple the management of these resources with vRealize with the underlying resources provided by GCP. So if you use vRealize Orchestrator or vRealize Automation, VRO or VRA, you might be using this to automatically provision new applications. So for those of you, if you have a blueprint, basically this is a portal that your own self-service users can go to click on deploying, say, a 3-tier web application or provision a database instance. Normally what that would do is in the back end, it would actually provision a bunch of virtual machines running on vSphere. But with this plugin, what we've now added the capability is you can provision GCE VMs running on Google Cloud using that same portal. We can provision Google Storage. And now you have this consistent management plane, but you have resources, the compute and storage and networking capabilities that are provided by Google Cloud instead. And then now you can take advantage of many of the things and many of the benefits that you have from running in a public cloud, namely that you have the global on-demand infrastructure. You can take advantage of the lower cost compute that you get from GCE. The custom machine types in particular are something that we found many customers look at and see as really a great reason to come to GCE because the custom machine types really get you to size your workloads to the minimum size necessary to satisfy the workload requirements. And then you can take advantage of other capabilities like fast boot times and live migration to avoid downtime. All right. So we've talked about application migration journeys and how to set up your architecture to support hybrid deployments. So now the question is, hopefully, how do I actually get my organization to go to this journey to really aggressively move to cloud? So what are some of the challenges that customers run through? A scary number is that 94% of enterprise migrations end up taking longer than planned and are over budget. This sounds like a typical home contracting remodeling experience. But some of the challenges are is that it's a very complex problem to solve. You might have thousands of workloads that you need to move. You may be moving from multiple different locations, some on-premises, some running VMs, some running on physical, some running actually maybe in AWS or another public cloud. And you want to now move to, say, GCP. There's other complexities to think about if you're running tier 1 applications. These are mission-critical workloads, and you're concerned about potential downtime and the risks to your business if you take down those workloads. And so how do you mitigate that risk? What is the best way to actually test? What's the best way to roll back if something, unfortunately, goes wrong? So as we look at a migration, it's really important to think carefully about how you're actually going to move through it, because it's not a simple process. It actually involves a lot of process change. There's a lot of social issues within an organization to be able to enact a really large migration like this. So if you break it up into phases, generally we think about it as an assessment phase, a planning phase, a third phase where you're actually doing the migration, and then after that, you're not really done. There's an opportunity to really optimize afterwards. And so thinking about this process, I think, is helpful to ensure that you have a successful migration. So let's talk a little bit more about each of these steps here. So assessment. This phase is really looking at your existing environment and then discovering what applications are you running, what services and workloads, and then thinking about, well, which ones do I actually want to move, which ones can I move, and why would I move them? So what's the business case? Are they running on hardware that's actually going to be end-of-lifed? Are there upgrade cycles that are naturally coming? Do you have a data center closure coming up? Are they part of an acquisition and you want to actually consolidate infrastructure? Those are just a few examples of typical business cases you might be thinking about. And then you want to estimate the cost. So how much is it going to cost to do the migration? And then after it's moved, how is that going to compare to the cost that you have for running that workload today? And then finally, choosing a migration path. Going back to those journeys we talked about earlier, which ones do you want to lift and shift? Which ones do you want to lift and refactor? Or which ones do you want to actually just completely rewrite? There are many tools that are out there. We work with a lot of partners like StrataZone and Cloud Physics and Cloudmise, among others, that help you look at which applications make sense to move and how. So after you've done that assessment, the next step is planning. Again, many of you will have hundreds or thousands of workloads, so you're not going to move them all at once. So which ones do you actually want to move first? As you try to decide the sequencing of moving workloads, a really important consideration is dependencies. You know, if you look at the dependencies that any given workload has, oftentimes we've seen that you can be surprised at how many dependencies you might have on monitoring systems, on backup systems, on logging, on dependencies on databases, on just various forms of communication between different workloads. So it's important to do that analysis and then think about what pieces you all have to move together to have a successful migration. You also have to think about compatibility. So is there a certification that's necessary for your software to run on another environment? What kinds of regulations might you be subject to? And then finally, you want to think about building what we call a cloud foundation in GCP to land these workloads. Now, I'll talk about the cloud foundation in a second, but again, this is an area where there are a lot of tools that are integrated with GCP, again, from StrataZone and Cloudmise, but also risk networks that help you figure out some of these dependencies when you're planning your migration. So at the Cloud Foundation level, this is basically how do you set up GCP to be prepared for you to move a large set of workloads and then land them so you can operate, manage, and monitor them from essentially day one. So think about from an identity standpoint. What IAM policies are you going to be defining? What resource hierarchy do you want to set up with respect to your organization, projects, and folders? Then thinking about security policies for each of those resource entities and groupings. Who and how do you want to provide visibility in logs and resources? And then thinking about network policy. Earlier I talked about the VPC, but within it, how do you want to set up your subnets? What kind of network devices do you want to deploy? What kind of firewall rules do you want to take from your on-premise environment and move to GCP? Or what new firewall rules might you want to be adding in this new environment? And then finally, there's a bunch of work on the billing side that you want to be able to think through. So working through these details in parallel to while you're doing the planning is an effective way to make sure that your migration moves smoothly. And there are many practices that we've been developing with the PSO organization to help kind of get you started on developing this cloud foundation. So after the assessment and planning, now we get to migration. There are a couple different approaches you can take with migration. Usually this is assuming you're starting with virtual machines, but sometimes it could be coming with workloads from physical machines as well. You might have some that you have disk images on premises, and you could just import those disks, create new VMs, and start running in cloud. But for more large-scale migrations, typically you want some tool to automate and orchestrate a large-scale migration, especially if you're talking about hundreds or even thousands of workloads. There are a variety of tools out there. Cloud Endure is one of our partners, and the other one is Velostrata. And I want to talk a little bit about Velostrata in particular, because this was an acquisition that we announced a few months ago. They were a great partner of Google's, but we found that they were a very complementary product, complementary technology, and really the team really fit very well with Google. So we saw that this was a way to help accelerate and simplify the journey that our customers are going to have when trying to move many workloads to GCP. The Velostrata product is designed specifically to support migration and for enterprise use. And I'll give you some examples of why that is in a second. So if you think about the general process of migration, what you typically have is your VMs and storage running on premises in a data center, and you want to get it over to the cloud. The typical migration, you will take all of your data, copy it over, and once you've done that, then start running your virtual machines. But the key insight from the Velostrata team is that you don't necessarily have to have this dependency of compute on storage. And instead, what you should do is look at how you can stream your data, and then decouple remove this dependency. So essentially what happens with the Velostrata technology is we start copying some of the key data from the VMs running on premises and bringing them up to GCP. And then we start the compute in VMs on GCP with only part of the data in GCP, while the remainder of the storage is still streaming in the background. And what this allows you to do is actually start running workloads in minutes rather than days or hours or weeks. And this leverages a lot of smart prefetching of data, WAN optimizations, and a lot of great technology to help make this a reality. But a picture is probably worth 1,000 words. I apologize a little bit. It's probably hard to read some of the text on this graph on these screens. But on the x-axis, this shows time for a typical migration. The blue line shows the number of VMs that are migrated. And in this case, this is a picture showing up to about 400 VMs. And then the green line is showing the amount of data. But I think it's more interesting to zoom into one of those boxes that looks at what happens over a period of 2 weeks. So again, this zoom in shows the migration journey for 75 VMs that have about 6 terabytes of data. And what you'll see is that after the first week, not much has been happening. Essentially, that was a proof of concept phase, trying to take a couple of VMs, trying to move them over, see how things work. And then right in the middle, there's that big vertical blue line. That's when, essentially in probably what was an afternoon, but certainly less than a day, about 70 VMs were spun up in GCP. And then the data is streaming in the background. And what you'll find is that at that point, 75 of these VMs are already running, even though the large majority of the data is still in your on-premise data center. And then it's not for a few days until a few days later when essentially the data migration is completed, the 6 terabytes of data. But in that period of time, you're already up and running on GCP. So you've been able to accelerate your migration of these 75 VMs from about 3 days down to a number of hours. This is a great accelerator for the migration process. So why is this important? I mean, obviously, saving time is great. It allows you to move workloads more quickly. Now you can think about moving a lot of workloads easily over a weekend, rather than thinking about, well, if I have to move a lot of applications and thinking about all the dependencies, maybe I would have to take services down for multiple days. And oftentimes that just becomes very difficult to get approval from the application owners. It also, of course, saves time from your staff. If you can save time for every VM that you move, think about the multiplicative effect this has if you're moving thousands of VMs. It also allows you to make decisions much, much more quickly. And in today's world, we want to be able to move fast. We want to make transitions quickly and make decisions quickly. So if we can do a POC very quickly, and then we can actually move certain workloads, we can realize, OK, yeah, this is going to work. This makes sense. Let's do it. Let's get it done. And there's also always the failback. What I didn't mention earlier is that the Velostrata technology, since it's streaming data, it continues to have a copy of the data on premises. So if it turns out you did something wrong or you need to fall back, you have that insurance policy available. You don't actually have to take a long downtime to move the workload back. And sometimes this will happen because of those nasty dependencies I mentioned earlier. You might have realized, oh, wait, there's this domain controller that I should have moved, but I didn't move it yet, and so now the application isn't working. So let's move it back, get it fixed up, and then redo the migration. Ultimately, this together can help accelerate the migration process. And given that a lot of these migrations are complex organizationally, there's a lot of process involved, putting these solutions together and using Velostrata can be extremely valuable. Now, most of this time I've been talking about moving your VM workloads. But in addition to migrating your virtual machines, you may have a lot of data that you need to migrate as well. So the data transfer appliance from Google Cloud is a solution that we've provided that allows you to move large data sets. So here is just shown an image of a 2U version of the transfer appliance. There's also a 4U version, and they support up to 100 terabytes and 480 terabytes, respectively. Compressed, you can get up to a petabyte. But basically, this is as simple as going to request a transfer appliance in your customer console. You receive it, you put it in a rack, you start filling it up with data, and then once you have it filled with data, you ship it back to us, and then we can move your data into, say, GCS. So many of our customers have said they have multi-petabytes of data, and the thought of having to stream all that data through the network is challenging. And so the data transfer appliance is one solution available if you have large-scale data migration, whether for big data use cases or potentially for other VM-like use cases as well. So in the last 45 minutes or so, I've talked about different application journeys to get to a cloud-native future in your digital transformation. So it's important to think about what makes sense for the different applications that you're going to move, and then pick the best journey that makes sense. We have a set of products and solutions designed to meet you where you are and help support you in this important journey. Over the next 5, probably 10 years, we are going to continue to be in hybrid environments. We're going to have on-premise data centers and public cloud environments. And so it's important to think about how do you want to manage this transition over time, start to adopt the technologies that allow you to make these gradual transitions that help you bridge today to the future. And then look at how we as Google can help partner with you, whether through PSO, whether through the customer engineers and the engineering teams and product teams, to help you successfully migrate to Google Cloud. With that, I just wanted to share, there's a number of sessions the next couple days that go a little bit deeper on some of the topics that I've talked about. But hopefully you found this helpful, and good luck with your journey to Google Cloud. Thank you.